Proportional relationship using unit rate as the slope. This is 8.4b and Mr. Taylor here. We will take a look at the unit rate of a particular problem and when this unit rate will be the actual slope of a particular problem. We need to be clear on definitions and the comparison between unit rate and slope. So first of all, make sure you understand that unit rate is a ratio, and we know that a ratio is simply a fraction between two different units, and one of the terms, either the numerator or the denominator, will be 1. And on the other hand, slope is just simply the steepness of a line. We also can say that it's the rate of change in the vertical line compared to the horizontal line. And we're talking about here just y over x. We also can denote it as rise over run, or changes in y values divided by changes in the x value. And we get that from the actual slope formula itself, which is y2 minus y1 divided by x2 minus x1. And when we say y2 and x2 and y1 and x1, we're talking about some first value. Let's say if we have 3, 0, and then the second value is 4, 2, then we can say that this is our first value of x, this is our first value of y, this is our second value of x, and our second value of y. So then that's where we get the y2 minus y1. We also notice that when we say unit rate and slope, we're talking about, in this particular instance, a linear proportionary relationship. And when we say linear, we're talking about a line. So what we're doing is we're looking at a graph that's going to give us a straight line, whether that line is, well, let's say rising up and to the right, or falling down and to the right, or the line could be constant, which will give us a horizontal line, or y is equal to some value. It'll always pass through the origin, which will give you your first, well, I will say first, depending on whether it's a real world situation or not, but it'll always give you 0, 0 as it goes through the origin, and is represented by y equals k times x. And guys, in this case, as you know, hopefully, that k is the constant of proportionality, and it's really the same thing as if we said slope is equal to y divided by x. If we were to write an actual line of an equation, we would write it as y is equal to mx plus b. So if you notice here, my k and my y serve the same purpose. The only difference is b in this case, if it runs through the origin, if it runs here through the origin, b is 0. So we can say that y is equal to m times x because b is 0, no value, and that's the same thing as y is equal to kx. When we're graphing unit rate from various representation, we can do so from a verbal representation, we can do so from a numeric representation, from a tabular representation, and a symbolic and algebraic representation. So we want to take also a look at the connection between unit rate and proportional relationship as it compares to the slope of a line. So we have a simple example, and I know you've seen it before, but again, just make sure you understand. When we say something like milk is sold at $4 per gallon, and I've told you in the past, as long as we're not adding nothing to this, such as plus $2 for the bottle, then we know that this particular $4 a gallon is a proportionary relationship. But we can represent this in a tabular or table form by looking at if we took gallons in cost or gallons in money, then which one depends? Well, the actual cost depends on how many gallons you buy. So then that means if this one is, let's put it like this, if this one is dependent, if this one is dependent on X, then X is the independent. We have to make sure that we understand that, independent, and Y is the dependent. So in this case, gallons is independent, and of course, how much it costs depends on how many gallons you buy. So we can set this table up. We can do so without the author giving us any kind of number. We know that if we buy no gallons, we pay no money. If we buy 1 gallon, we pay $4. 2 gallons is $8. 3 gallons is $12. So remember what we said about unit rate. We said that the unit rate has one of the parts as 1. So there we go. And our unit rate in this problem is 4/1. Or should I say $4 to every 1 gallon. All right. Or 1 gallon costs $4. Either way you look at it. So now, from a verbal representation, which is the second thing we'll look at, if milk is sold at $4 per gallon, then the problem situation can be represented by $4 as the unit rate. Now let's look at the difference between unit rate and slope. So we say $4 for every gallon, but if we take unit rate and make it from a numerical standpoint, which means let's just take away the actual units, which is dollars and gallons, we will have 4/1, which can be simplified to 4. Okay, so in some cases, the unit rate and slope won't be the same. Say, for instance, if we had slope, and this slope, we would say M is 4/5. Well, 4/5 wouldn't be the unit rate. What we'd have to do to get the unit rate is divide, and then let's do it. We will take 5 and divide it into 4, and we will get a unit rate at 0.8/1. So please keep that in mind, that sometimes you'll come up with a slope and you will have to make sure that one of these terms, either the numerator or the denominator, must be 1 for you to get the correct unit rate. And then now the last thing that we want to look at it, if we look at it from a graphical standpoint or a graph, and if you notice, here's our points that we looked at first, 0, 0, and of course you're just going to chart that on your coordinate grid, and then here you have 1, 4, and then here you have 2, 8, and then here you have 3, 12, and then you plot those out. Now, of course, the author used a particular, just connected the points to create a line. But, we're talking about objects here. So since we're talking about objects, we know literally in the real world scheme of things, we will just have, if they're selling them per gallon, these would be a discrete figure. But anyway, that's what the graphical aspect look like. If you notice the little triangles here, the little triangles is how we went on a graph. We do rise over run to find slope. So again, we're looking at the unit and the slope part. Well, we start at 0 and we go up 1, 2, 3, 4, and over 1. And what the author did is he went over 1 and up 4, but still 4 over 1 would be give us the same slope. And here we're going up 1, 2, 3, 4 over 1, and 1, 2, 3, 4 over 1. So each particular point on the grid gives us a rise over run as 4 to 1. So now, from an algebraic standpoint, if we're looking at it and we say that the actual formula of a line is y is equal to mx plus b. So we said that our slope here is 4. So y is equal to 4x, and my y-intercept is 0. So here plus 0, and that's what gives me y is equal to 4 times x. All right, this is the way we take a look at unit rate and slope. And if you have any questions, please do so by comments or let me know in class. You guys have a great day.